Okay, and now it's time to read the 3.2. Okay, this section is a little bit harder, so be patient on this chapter because measures of spread. The keyword is spread. Then, if you can understand the concept here, later you will understand what the normal distribution and what the standard deviation is. Okay. Let's check here. Variability is an important idea in statistics. If you were to measure the height of everyone in your classroom, every observation gives you a different value. Absolutely. Okay. Then that means not every student has the same height. Absolutely. Thus, there is variability in people's height. If you were to take a sample of income level of people in a town, every sample gives you different information. There is a variability between samples too, okay? Variability describes how the data are spread out. If the data are very close to each other, then there is low variability. Again, the data are very close to each other, there is low variability. In the opposite side, if the data are very spread out, then there is a high variability. How do you measure variability? It will be give a to be good to give a number that measure it. This section will describe some of the different measures of variability, also known as variation. Okay, later we will read this term, variation. Okay, in example 3.2.1, the average weight of a cat was calculated to be 8.02. Again, previous section, we calculated that we know the average weight of the cat is 8.02. How much does it tell you about the weight of all cats? Can you tell if most of the weights were close to 8.2 or the weights really spread out? What are those high is the weight and those the weights? You know this, that the center of the weight is 8.2 pounds. You need more information. Okay, let's check here. Definition of the term range. Range of a data set, that is the difference between highest and lowest data value. Again, between the highest and lowest, and technically we can use range equals highest value subtract lowest value. In other words, maximum minus minimum. Okay, let's check this one. Look at the following three sets of data. Find the range of each other. Okay, what's the definition of range? The maximum minus minimum. Okay, and from this set, we know the maximum 50, minimum 10. Okay, for question A, we know the smallest, the range equals the minimum 10, maximum 50. That is 50 minus 10. That is 40. That's for our first question. Question B, 10, 29, 30, 31, 50. Okay, the same way about the B. The maximum 50, minimum 10, the same. The range is 40. How about the number 3, question C? We can observe, okay, 32 is the maximum value. 32 minus minimum value 28. The value is 4. Okay, the range is 4. Sorry, the range is 4. Okay, again, the first one, question A, the range 40. Second one, 40. Third one, 4. Third one, 4. Okay, alright, check it. Mean 30, median 30, range 40. Second question, median 30, mean median 30, range 30. But we can observe the black spots very evenly distributed around the line. But the middle three, they are getting together. But the minimum value 10, maximum value 50, far away from the center. And question number C. Question number C, mean 30, median 30, range only 4, just 10% of the previous two. So can you understand what is the spread? What is the spread? Because the data from 10 to 50, those two data, we know they are different, but they have the same mean, the same median, the same range from question A and question B. About question C, has the same mean, has the same median, but different range. We can observe that the black spots over there, yeah, we know it's completely different patterns, different modes. Okay, if you can accept this kind of concept, let's move to next. Okay, this part is a little bit of tough. Be concentration on this one. Example through 3.2.1. Finding the deviations. What is the deviation? The range doesn't really provide a very accurate picture of the variation. A better way to describe how the data is spread out is needed. Instead of looking at the distance of the highest value from the lowest value, about looking at the distance each value, the distance is called deviation. Previously, we call it variation. Now we call it deviation. Different, close but different definition. Suppose a vet want to analyze the weight of cats. The weight in pounds of 5 cats are 6.8 blah 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 blah. Then solution. Here that the x equals the weight of cat. The mean of the data set is x bar 8.02 pounds, like this one. And x1, 2, 3, 4, 5 numbers. When we use the x number minus the average x bar, we got minus 1.22, 0.18, minus 0.52, like this one. If we want to know the average of the variation, you need to add them together. We can add minus 1.22, 0.18, minus 0.52, 1.38, and 0.18. Add them together, we got a 0. Why? 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 Because the original number 6.8 minus the average x bar, because the 6.8 is smaller than the average, then when the small number minus the average, we got a minus number. Is it okay? The other one, for example, 9.4 is larger than the average. When we use 9.4 minus the average, we got positive number. Then we add all differences together, we got a 0. It makes no sense. How can you do that? Not me, I'm not smart, because the scientists created this way. Very easy. Just make this one to the square. Again, it's negative number, right? We make the square number of it. Square number 0.18, make a square number. Then add them together. Then divided by 1, 2, 3, 4, 5. Then take a square root of it. It's very smart, but another person created. Maybe 100, 200 years ago, the scientists created it. Let me explain this one. See, take a square root, take a square, make a square of the number. We know 1 minus 1.22. The square number is positive 1.4884. The second one, 0.18. The square number is 0.0324. You may ask, why? It's smaller than this one. Yeah, because it's smaller than 1. When take a square, cubic root, no, sorry, cubic number, square number, cubic number, it becomes smaller. It's very normal. And 9.4 minus 8.02. The number is positive 1.38. And we take a square value of it, it would be 1.9044. This time, we'll put everything together, add them together. Originally, it was 0. But now, we try to make it as positive. How can we make it positive? We use square number. Then put them together. That would be 3.728. But originally, if we got the distance together, that will be 0. After we make it a square, and add them together, we got the 3.728. Question? Sure. You are kidding me, because the distance from the average for the 6.8, that is this distance. Minus it means the average and the point is on the left side. This distance is negative. 9.4, this distance is positive. It's positive. It add them together, all distance are cancelled, become 0. But when we make them as a square number, make them square, add them together, all are positive. But how can you return it back to the original distance? Very easy. 1, 2, 3, 4, 5. 5 members here divided by 5. Then take a square root. This part is very hard way to imagination, to image it. Very hard. But calculation is very easy. So I slow down, because in the future, I promise I will tell you how to click it, how to do that. You can get a number in few seconds, but you still don't know the principles here. Again. This part is very, very important. So I explain it again. Originally, we said one thing here. We know there is a line. There is a line like this one, and the average is here. Average is here. We call X bar. We call X bar here. And the X bar is 8.02. 8.02. Then the number is 6.8. Where is the location of that? 6.8 should be here. Should be here. And the other one, 9.4. 9.4 should be here. Okay, we know the number 9.4 larger than the average. The other 6.8 smaller than the average. And we see the distance. The distance is here. Distance is here. And the distance number is minus 1.22. Minus 1.22. You may ask, you can switch that. No, according to the definition, the number minus the original value minus the average value. Original value is smaller than 1. Sure, we got the negative value. Absolutely. But 9.4 is larger than the average. Thus, the subtraction, we got a positive number. Okay, so this one is minus. And the other one is 1.38. Positively 1.38. Thus, when we add all distance together, it becomes 0. It becomes 0, right? So it makes no sense. And now you just do one thing. If we have chance to do this, try to make it square number. Then we make it square number. Oh, now it becomes positive. If you, I-Yuan daughter, can you tell me why it become positive? Please let me know. If you really don't know why it become positive after the take the square number, please let me know. You need to learn more math, okay? Okay. Then we have how many distances here? 1, 2, 3, 4, 5. We have 5 sets. Then we add them together. 1, 2, 3, 4, 5. We got a sum. The sum is here. We add them together and we got a sum is 3.728. So far, okay. So far is okay. Because this part is very important. Okay, so I may postpone the break time a few minutes, but I want to explain this part. I want to finish it. Okay, then next. Now the average of total squared values, we call it squared deviations. The only thing is that statistic is a strange average here. Instead of dividing by the number of the data value, you need to make the value minus 1. Again, minus 1. We added 5 sets of numbers together. Theoretically, we get an average. We should use 5 is okay. But now it's sample, thus we need to subtract. We need minus 1 in the denominator. Try to memorize this thing. Because the principle is very, very, very hard. Only one situation, you don't need to minus 1. Your numbers are the population. But your numbers is the samples. You need to subtract 1. Why? I don't know. To be honest, I don't know. Because I study about the principles, I still cannot understand it. I don't know why. But memorize it here. Again, 3.728 is the sum of all squared values. Then put them together, divided by the number set 5 minus 1. That will be 4. And this kind of we called sample deviation or variation, and later we take the square root of the value. Then here is the ideal situation to present the distance. See it again, let's check it again. At the square root value 0.9665. That is a kind of average about what? About this 0.18, 1.38, 0.52. We don't consider the minus symbol. 0.18 and 1.22. Is it okay? It's very hard. So next week I will review the concept here, because in the future you just click and type in your computer, then you got all average, you got all standard deviation, you got all variance, but you don't know why. So this moment is the key stage. You need to understand. Let me say it again. When the value minus the average, we got that value. And value can be negative, can be positive. If you add them together, that is zero. Absolutely, because when the distance from the left side smaller than the x average, x bar, this distance is negative. When the number larger than the average, this number is positive. You add them together, that is zero. Zero emits this sign. It makes no sense. The scientists created one way. They make a square value of the distance, then add them together, then get the average. Okay, but the average is a little bit weird. Why? Because we know average. What does it mean? Why have 5 people? We got their money, then divided by 5, I got an average. But to calculate the variation or standard deviation, we need to minus 1. This guy is going crazy? No, it's very important. In the denominator, the simple number minus 1 in the denominator, and the numerator is the sum of the square value. Is it okay? Excuse me? Drink water, go outside. Okay? Then we got the number square root, and the 0.932 is from the denominator 4. Denominator, how can you get that? Your total number 5 minus 1. Thus, minus 1 is the most difficult thing to imagine here. Okay, let's move here. And in here, we call sample variance. Again, what is variance? What is standard deviation? Again, variance without taking square root. Standard deviation, we should take a standard deviation, so we could take the square root. In other words, if we have the s and make it square number, it's called variance. If we take a square root of the variance, it's called standard deviation. Okay, actually, we always use standard deviation. Make a square root, square root. But the most useful number is this one, standard deviation. In the future, you study something about economics, about business. Most useful term is this one, not this one. But why we want to know this one? Because it's a transition state. It's transition. After that, take a square root, we got this one. Okay, have 10-minute break. Sorry, I postponed the break time. See See you later.